Ever wondered how a quantum computer actually thinks? Most people think it's magic, but it's actually a lot like the computer you're using right now, just with a mind-bending twist. In classical computing, we use bits, zeros and ones. We process them using logic gates like AND, OR, and NOT. In the quantum world, we use the gate-based model or the circuit model. Think of it like a musical score. The wires are the qubits, and the gates are the notes that tell those qubits how to change their state as they move through time. But unlike classical gates, these gates can do things that defy everyday logic. Let's look at our first tool, the Hadamard Gate, or the H-gate. In your laptop, a bit is either a 0 or a 1. But when we pass a qubit through an H-gate, it enters a superposition. It's not just 0 or 1 anymore. It's mathematically both at the same time, $frac. 1 backslash is $. Imagine spinning a coin on a table. While it's spinning, it's not heads or tails, it's a blur of both. That's what the H-gate does. It prepares the workspace for quantum calculation. Next, we have the Poly-X gate. This is the quantum version of a NOT gate. If the qubit is 0, it becomes 1 and vice versa. Simple, right? But the real power comes with the CNOT gate, or controlled NOT. This gate uses 2 qubits. It says, if the first qubit is a 1, then flip the second qubit. If not, do nothing. When we combine the H-gate and the CNOT gate, we get entanglement. This is what Einstein called spooky action at a distance. We link 2 qubits so that whatever happens to one instantly affects the other, no matter how far apart they are. The final step in any gate-based circuit is measurement. Quantum computing is probabilistic. All that superposition and entanglement happen in the dark. Once we measure the qubits, the superposition collapses, and we get a string of classical zeros and ones as our answer. The goal of a quantum algorithm is to use these gates to interfere with the probabilities so that the wrong answers cancel out and the right answer is what we eventually measure. That is the gate-based model. It's the roadmap for companies like IBM and Google to build the future of medicine, encryption, and AI. If you want to see what this looks like in real code using Python, let me know in the comments, and I'll walk you through a Qiskit script in the next video.